Dude, thanks. Hi, everybody. Welcome back. I'd like to say thanks to Crunch for inviting me. This is my first time in Budapest. Absolutely delighted. Spent the weekend just, seeing what you can see in a weekend. The lights are super bright, but I'm kind of curious. Who is from near here? Can I see hands? Basically everybody. Hi. Okay, who is not from near here? Okay. Anybody? Any of my fellow Americans here, just out of curiosity? I have like 3 hands. Hi, guys. Okay, we'll talk later. Anyway. Hey, great to see you. I am from Denver, and that's kind of in the mountainous region, about 2/3 from away from where the New York Times is, towards where Silicon Valley is, kind of in the middle, and it's a great place to live. So, I work for a company called Confluent. Confluent makes a streaming data platform based on Apache Kafka, and it's Kafka that I'm going to talk to you about today. I want to build a whole streaming platform. I have about 40 minutes, and that timer, by the way, is just blinking one time. We have until about 5 minutes past 11. I want to build a streaming platform from the ground up, starting with some basics. And here's a basic that I'd like to start with. I'm going to assume that you are a person who writes computer programs. Now, maybe you are more of a data engineer or an analytics person, but I'm going to say I don't really buy it as a distinction. Like you really, basically, you write programs, whether you think you do or not, even if you're an analytics person. That is kind of what you do. So you are some kind of programmer of some stripe, and it's worth just asking yourself, what do your programs do? Now, sometimes you've got a big pile of data and you just need to crunch through it, a good old-fashioned batch analysis kind of thing. But usually, if you're a more conventional developer, what you do is somebody submits a web form or posts something to you, and you write it to a relational database, and then later on, you get it out of the database and you serialize it as JSON and you send it out. It's kind of depressing, actually, if you think about it. I mean, that's like most code right there. Don't dwell on that, because I love this profession and you probably love what you do. Hate to reduce it like that. But the point is, a thing happens, you do some stuff, and you have a result, right? That is, I'm going to argue that your programs always process events. Again, sometimes, big pile of data, write a little Python script, crunch through the big pile of data, come up with a result. But usually, that kind of analysis is trying to come up with some sort of algorithm or some sort of process that you later want to automate and make the response, the code that responds to an event, all right? Life is events. Now, there are things out there. It's not like there are no entities in the world. We have to worry about entities at some point, but our code processes events. And there is, I'm just going to say that little box, that's an event. And let's try to build an entire world, an entire platform on top of this little thing. All right? That's just a nondescript little thing that happens. No structure at all. The thing is, a lot of events will happen. A lot of different kinds of events are going to happen, so we'll need to impose some structure. All right, so I'm going to introduce a very complex data model right here, just to be a little specific about what I mean by event. Let's say an event is a key-value pair. Let's not worry about the formatting of the key and the value yet. Just every event is a key and a value, a label, and then some data, right? So, what is, kind of summing up this notion, I'm starting with this notion of events. What we do is process events, just to make sure your imagination is going in the right direction. What could these events be? Well, maybe you do an Internet of Things kind of thing, right? Could be a sensor reading, or a ping, or a, Tim walked by his thermostat, or whatever. This could be a customer interaction. This could be somebody clicked on a thing, somebody searched for a thing, somebody bought a thing, somebody left a comment, right? All of those are events. This could be a change in a business process. We're kind of in a historic rail yard here. Something got moved on to some kind of shipment thing, or moved from place to place, or somebody placed an order. That's kind of a business process change. All these things are events, right? Maybe you are a person who builds microservices or is in the process of refactoring something unpleasant to something that you imagine will be more pleasant and will be a bunch of little programs. The output of any given microservice is modelable as an event. All right, so it's possible to take this very event-centric view of life, and I'm just going to recommend that. We're going to start out, we have these key value pairs, events sort of rule everything around us. But we're going to have to organize those events. We're going to have to keep track of them in some way. So let me add a layer on top of this. We're going to call those things topics. We've got these key value pair events, but we're going to need to organize them. We're going to need to store them, and I'm going to put them in a thing called topics. This is very conventional language for legacy messaging systems. And the platform I'm building is not a legacy messaging system, but let's just say we have this thing. We'll call it a topic, and an event comes in, and I'm going to put it in that topic. Another one comes in, and I'm going to put it next in line, and next, and next, and next. I'm going to put these things in order in this topic. So I've got a key value pair, and now I've got a means of storing them in order. All right, so we're starting to build little elements of our platform here. Well, what is this topic really? You want to think of it as a log. If you're tempted, by the way, and I'm assuming most of you here are familiar with basically what Kafka is. It's not like there's some great surprise. I'm going to unveil this thing at the end, like, oh wow, he was talking about Kafka the whole time. I had no idea. I'm sure you get that. But you want to think of a topic in Kafka not like a topic in a traditional message queuing system, but you want to think of it as a log. It's a record, okay? It's not just a buffer between processes to where when you read an event, it goes away. But this is a persistent log of events. That's what this model is. We've got events. Events are key value pairs. We're putting them in logs. These logs can give us a strict ordering guarantee. They're going to remember the order in which events happen, which is kind of all we can say about events, right? They happen in a certain order. That's sort of it, right? So we've got an ordering guarantee, and we're going to be able to read and write to this in constant time. Anytime I put a new event on the end of this, we'll talk about how that works later, that happens in constant time. Anytime I want to read a particular event out of this log, that happens in constant time. The bummer with reads is that they're not super fancy. All I can do is kind of go to an offset in the log. I can do that, constant time, and get the event there. I can get the next one. I can get the next one. I can get the next one. But logs, that's all you really do with them. You scan them. And that would be a terrible life if that's all we had. Now, it's all we have so far, since I'm trying to build this piece by piece. But I want to make sure that you're thinking, hey, I hope we come up with some better way to deal with this data later on, because just scanning through a log kind of is not a great way to live. But there are some other problems we have to solve first, building this platform up a piece at a time. And one of those is partitioning. So a couple of things, again, a lot of people, when people think about Kafka, again, it's not like a new topic for most people. It's the thing most of us are familiar with. And people either think of it as like a legacy message queuing system, which it is not really, or like a big giant pipe that you use to connect things into Hadoop. That's a kind of an old-fashioned way of thinking about it. Unfortunately, it still lingers in our minds. One of the things that separates Kafka from legacy enterprise messaging system is this notion of partitioning. So this log that we've got here, right, one of these logs we just built that is, we called it a topic. That's an ordered collection of messages. What we can do is we can split that up into pieces. So logically, this is one named collection of events, but I'm going to say it exists in 3 partitions. Now that number can be 3, it could be 30, it can be 300. You can have lots and lots of partitions in a topic. But now that we've broken it up into pieces, well, when those key value pairs come in, we have to decide where to write them, right? I've got a key value pair. What I'm going to do is I'm going to take that key, I'm going to hash it, and that hash is going to tell me which one of those partitions then it gets written to. So that'll go to partition 2, that'll go to partition 2, That one will go into partition 1, and so forth. So partitioning our topics is a key thing that sets Kafka apart from legacy enterprise messaging systems, in that it helps us scale, right? This lets us scale writes. If lots and lots of things, lots and lots of events are arriving into a topic, it may be that there are too many for one machine, we call that machine a broker, for one broker to be able to handle all that publishing of data, right? So you want to split that up. This now is going to provide us scalable writes. Also, since, as I said, topics are logs, they're not really queues. These are durable, persistent, I can store. In fact, our keynote speaker was from the New York Times. The New York Times famously published a blog post about a year and a few months ago, about their use of Kafka, and all of their story content from 1860 whatever, which is when the Times started, and in the United States, that's a super long time ago. So when the New York Times started in the 1860s to the present, all of that story content is in a Kafka topic. It's actually stored, with those dates over that whole time. So you could store data for a really long time in a topic. If there's lots of events happening, you want to store them for a long time, you might need to scale out storage. So this provides scalable writes, scalable storage, scalable consumption. We'll talk about that in a few minutes. The downside, okay? This is where Kafka becomes a distributed system. And you all know that distributed systems are, say it with me, terrible, right? Everybody knows this, and for a number of years, I've kind of made my living in the distributed systems world, and I don't quite know why I'm doing this to people, because if you could just write a single piece of code in Python, and it runs on one core, and you own the whole file system, what a great life that is, right? You could leave work at 3, you could spend time with your family or have hobbies or something, but when now we take that nice system and turn it into a distributed system that's running on all kinds of machines, these partitions are broken up, something bad is going to happen to us. Now, of course, the upside is we get to build bigger and cooler systems, but the downside here is that ordering is now just within partitions. I no longer have global ordering of all my events. Each one of my partitions has a strict ordering guarantee, but between partitions, I lose order. So, for example, that New York Times application where they have all their story content, not including media that's stored somewhere else, but all the story text and metadata, that happens to be a single partition topic. So you have global ordering. But in general, when you scale out, you lose that. Therefore, the selection of key, remember I said events are key value pairs? What you pick for your key determines the space in which that ordering guarantee exists, right? Because all of the same key, all of a common key will always exist in one topic, or pardon me, one partition. I know the same key, if it's user ID, and I'm say user 24601, all of the events for user 24601 are always going to show up in the same topic, because they're always going to get hashed to the same thing. So key selection becomes a primary data modeling concern. There's literally a half an hour more stuff to say about that, but this is an overview. We're trying to build a platform just to get some ideas into your head and to see where this goes. Because at this point, the question normally comes up, hey, wise guy, you've got all these partitions. You said it's a distributed system. Don't we have to replicate? Just briefly, I'll tell you, yes, of course we replicate. That's a very important thing that Kafka does. And this underscores a key part of the platform. Remember what I said about topics, that reading out of a topic does not make the data go away. Data can live in topics indefinitely. You configure per topic how long you want data to be retained, usually as a time, right? So that you can set that to a day, 7 days, a year, infinity. Those are all options. So Kafka stores data. It's an actual thing that you can use as a system of record. It's not just a pipe, it's not just a queue. It wants to be a system of record. And by the way, this talk is not about this, so I need to watch myself. But just kind of that fact ends up kind of creating these little architectural tendrils that the fact that Kafka can store stuff and there can be lots of readers on a single topic and the data can last a long time has tremendous architectural implications that are bigger than you'd think. Anyway, just leave that thought there with you. Replication, since this is a system of record, we have to make sure we replicate stuff, so let's just talk briefly about how that works. Those boxes there are brokers. Those are individual computers running the Kafka process. I've got a topic here that's split into 4 partitions. It's just one topic, 4 partitions, and if I didn't replicate it all, it would look like that, right? Each partition would just be on a broker, and if one of those brokers died, I'd lose the data. Well, obviously, that stinks. So what we'll do is we'll say, hey, let's make 2 copies for a total of 3 of each partition. So there's partition 2 with 2 copies, partition 3 with 3 copies, and we're trying to be smart about this. There are various levels of automation that different organizations have achieved to get this done. You try to be smart about where the partitions live. So all of the brokers have an approximately equal amount of work to do. There are command line tools you can use to script that. There are people who have built their own systems. There are enterprise management and monitoring tools available that can do this in an automated way. But that's the basic idea, right? So if one of those brokers perishes in flame, like broker 4, it's okay. Partitions 2 and 3 lost a follower. One of those follower partitions went away. The leader of partition 4 went away, and now that fails over to broker 2. In fact, I'll just do that again. See, the broker 4 has partition 4 colored in dark. That means it's the lead partition. When it dies, automatically Kafka's going to elect a new lead partition. There's always one of the partitions that's a leader, and anytime you write to a partition or read from a partition, you always write and read to that leader. The others are just copies waiting for something to fail, so you can fail over to those. So that's a super brief approach to that. Anytime you make copies of things that change, this is another terrible thing to do in a distributed system, and things about your life will be bad. Happily, Kafka provides relatively elegant solutions to all of the questions that come up, and because we're trying to build a whole platform in 45 minutes, I'm not going to tell you what those solutions are, but they're all available online, and they're interesting things, interesting ways that Kafka solves the consistency problems that come up when you replicate. But let's just leave it at that. Replication is there, it works, we can trust this thing to save our data. I mentioned that when you write data to a topic or read data from a topic, it always writes or reads to the leader, to the lead partition, right, when you're replicating. Well, let's dig into what writing and reading mean. And actually, let's just catch our breath for a second, and let me remind you what we've got. We started with an event, so there are going to be a lot of events happening. What our code does, we are programmers, we process events, that's what we do. These events, I'm going to say, we'll model them as key value pairs. We want a system for organizing them, storing them persistently in order. We call that a topic. We partitioned the topic, we replicated the partitions. We've got now a means of remembering what has happened and storing it in a durable and trustworthy way. That's what we've got so far. Now we're going to look in a little more detail about how we write and how we read. With that in place, we have all of the primitives we need. We're kind of going to have Kafka assembly language on the table after we look at producers and consumers. So we're almost halfway through building this platform. All right, producers. The producer is a client program. It's a program you write, and it writes data into a topic. And here we're just remembering that topics are partitioned things. And that stuff, that writing happens in a client program that you write. So the big box there, the partitioned topic, that is living in the Kafka cluster. That runs on a broker or brokers, hopefully, since it's partitioned. There are several brokers that are handling all that. That producer is a machine of yours. And I always want to say like machine or server, but we all know that could just mean container. Like what even is really a server anymore? It's a thing, you've deployed code, and that's what that producer is. Kafka supports lots and lots of different language libraries. Pretty much any language you want to use, there's going to be a binding for it. Its native language these days is Java. And how many Java developers here? I'm guessing, okay, all right, that's good, that's good. I was curious, Python? Crowd like, yeah. PHP. Why are you laughing? There's like, okay, fine, Ruby. Okay, there you go, thanks. Good to have you here. Anyway, historically I'm a Java developer, so the rest of you, we can still be friends. Now, this is Java code for a very, very trivial Kafka consumer, and all the details of this are not important. I'm not going to live code this. I don't want to totally walk you through everything, but I want you to see a couple things happen here. Number one, we have an object called payment. That is our domain object. We write that. We have an object called producer, and that is a connection to the Kafka cluster right there. And we create a producer record, which in the Java type system is called a generic. And we see here that the key is a string, and the value is one of our domain objects, one of those payment domain objects. We create this producer record object with an ID of our choosing and a payment object, and we say this is going to go to a topic called transactions. Then we send it to that topic. That's really the basics of how you produce. Here's my key, here's my value, what topic is it going to go to? Send. And that's it. Now, that's cool because it's really easy to understand. The fun ends real fast with that, and I'm going to walk you through how that fun ends in particular in just a minute. Now, again, producers, client applications, right? Programs you write, puts messages into topics. Under the covers, the important stuff that it's doing is the Kafka wire protocol, which, by the way, is all open and documented. If you want to write your own producer, you can twiddle bits and do all of that by yourself. It also makes decisions about partitioning. There are supported, and by supported I mean the company that I work for supports, well, Java is supported by Apache Kafka, but Go, .NET, C, and Python are all supported by Confluent, and pretty much anything else you want, there's going to be at least one community version of it. Like, there isn't a Confluent-supported Node driver, but there's a great Node library out in the world. So whatever, I forgot to ask, Node, I'm so sorry. JavaScript, hands. Okay, well, this is analytics and data engineering, so, not as many JS people. But there's a Kafka library for you, so don't worry. Now let's talk about consumers. Okay, so there's our partitioned topic. We're going to want to read data from that. Now the cool thing is, oh, by the way, just stop there. That one consumer process, if it consumes from that topic, the topic has partitions. It doesn't know. It's going to get messages from all the partitions. Every partition's message will always arrive in order. It's all you can do. Have to consume in order. But between partitions, the consumer has no ordering guarantee. It's going to consume all those messages, though. The nice thing is, I can write more than one, because consuming does not, as it were, consume, right? Having consumed, I can still, the message doesn't go away. That means I can have more than one consumer, and they can be reading from different places in those partitions. They have all their own offsets that are being tracked. Consumer code looks like this. Very, very similar. We call this method called poll, and that gets us a collection of consumer records, which again are typed things. I iterate over that, I get a key and a value, and in this incredibly sophisticated consumer, I print them to standard out. Take a picture of that if you want. You're welcome to use this code. It's actually, I got this from a repo called Confluent Inc/examples on GitHub, but it's great, great consumer code. All right, back to this. Our two consumers. What if we had too much work for one consumer to handle? Right? This shows one instance of each, not particularly fault tolerant, not particularly scalable. Like what if you add functionality to a consumer to start running some expensive machine learning model that automatically like retrains itself or something. You know, that would be a bummer. I wouldn't want to be limited to just one. Happily though, I have partitions. And before I said that partitions scale writes, storage, and consumption. So I can add consumer instances. That's just another container running that same app, or deploy that Uber jar to another root server, whatever it is, and the cluster automatically says, oh, you're the same consumer group, I'll just give you a partition, and I can keep going. Oh, add a third one. Well, here's a partition for you. Now everyone has a partition. It's like Oprah. But with only 3 partitions, I'm at the max of my scaling, right? I can add another consumer to the group, but it'll just be a hot standby, right? It won't have more work to do by default. Poor consumer B, I guess he doesn't have as much work to do. He hasn't scaled yet. But this scaling functionality is built in. So consumer, again, client application, you write it. What's it do? Reads messages from topics. These are horizontally and elastically scalable for free. Now, if you ever remember anything about a message, say you're grouping. To group, you have to make a hash table and then either keep a collection of things or run some aggregation. That is to say, you put stuff in memory, right? If you do anything stateful as a consumer, that automatic scaling up and scaling down that Kafka gives you is a little bit of a bummer, and we're going to need another layer on top of consumer groups to fix that, which I'm going to introduce in a minute. Same language support, it's everything. All right. Pretty cool, right? Like I said, at this point, if I just sent you away and okay, go build stuff. All right, I get it. I got topics, I got events, I can consume, and I can produce. That sounds pretty good. You go build stuff, and you'd create some applications, and certain patterns would emerge, okay? Like, well, there's this JDBC database. I connect to this database over JDBC. It's a legacy system, and I have to know when new records are inserted, new rows are inserted. And so you'd write like a little producer that pulls that database, and every time you see the next ID, you'd produce it into a topic. You could imagine that, right? I mean, you write that code 2 or 3 times, and what are you going to do? You're going to be like, oh, framework, right? And frameworks are great, because what don't you have when you write a framework? You don't have an insane business stakeholder telling you that all of these bizarre special case things need to happen that stink up your code with conditionals that make you mad, right? And that's what it's like when you write code that has to do things in the real world. The code is not beautiful. When you extract a framework, you're like, no, I'm the powerful one now. I'm going to make this perfectly beautiful thing. It's going to be like this platonic solid floating in the heavens, perfect and unmarred, except it's not your job to write frameworks, right? It's not. It's your job to write code that delivers value to the business. So we all have this temptation to pull frameworks out. But like our friend Admiral Akbar says, it is a trap, because, again, you're supposed to be writing code actually for these business stakeholders, even though they make your life hard. So the rest of what I have to talk about is the Kafka community's answer to that trap. This is stuff that you would build. You wouldn't be able to finish it, right? Because you'd get in trouble. You'd have to stop working on the framework and get back to the actual job stuff. But the Kafka community has kind of plugged in the holes of data integration, schema management, and stream processing. Let me just walk you through those pieces, okay? Start with Kafka Connect. Now, if I sent you away with producers and consumers, and you went and built things, and you got this kind of event-centric thinking into your head, and maybe you Googled for a talk of mine called microservices, or what's it called? It's something about commit logs and onions and microservices. I forget the title. Check it out. If you should Google those words, maybe you'll get to the right talk. But you say, hey, wow, I should really build whole systems this way. And you'd have all of these pieces starting to integrate with Kafka. Kafka kind of finds its way to the center, because it's this persistent log. It wants to find its way to the center of the system, and all of these other things are integrating with it. It's just that those integrations can be a pain. These are the frameworks. This is one of the frameworks they're going to want to extract. Well, Kafka Connect was Kafka's first thing where it said, hey, you know what? people are building this, let's get it right. Let's as a community, build one that we can all use. And what it is this, again, like it's a producer and a consumer. It's a client application that runs outside of the Kafka cluster that pulls data in from data sources, that's a source connector, and reads data, or consumes data from Kafka and writes it to data sinks. So on the source side, that's a producer. On the sink side, that's a consumer. All right, this runs on, again, in containers or servers. It is a clustered thing where I now deploy this connect process, and I can scale that cluster up, scale that cluster down. It's doing this I/O with whatever legacy system. I define legacy system as a thing that's not Kafka. Slightly opinionated. I can get away with it. Well, I tell myself I can get away with it. I guess it's up to you. But anyway, you have this scalable thing where I can add workers and I can remove workers according to what my needs are at the time, and they all keep track of the last message read from the outside system, or all that stuff. All that stuff's tracked for you. Connect has a little REST endpoint. You post a blob of JSON that looks like this to it, and it says, oh, okay, hey, wake up, guys. We got a customer. Let me go source from that Postgres database. Every time I see a new record, I'll produce it into a topic called whatever it says here. That topic is movies. It's called movies. The other neat thing, so not only does it keep you from writing code, but the other neat thing about Connect is that there's this ecosystem of connectors. You don't want to have to write the JDBC connector. You don't want to have to write the Elasticsearch sync connector. Probably been done before, and we all know that each one of us is an awesome developer. Probably somebody got that done and tested it, and it worked, right? So this is a site called hub.confluent.io, hub of all connectors, great place to go for this stuff. So Connect, you want to think of it as a declarative data integration framework, extensive community library of connectors. It itself is a horizontally scalable and fault-tolerant piece of infrastructure. Those things, by the way, if Connect, you're paying attention, and you thought, that sounds a little bit like a consumer group, it actually is a little bit like a consumer group. That same protocol is reused by Connect. Also has an API, so if you need to write a connector, if you don't find your thing in what I described as the extensive community library of connectors, that API is pretty well documented and pretty approachable, so you can write your own connector for your internal thing. Pardon me. All right, let's talk about schema. You guys remember this, right? These little key value pairs getting written to that topic. I want to say, Tim, you just said value, whatever that is. What is that thing? That value is important if you consider something like a microservice that validates orders and produces them to a topic. Well, who's going to care about validated orders, right? You might have a loyalty program down here that wants to read orders. You might have a shipment service that integrates with some mainframe that talks to the warehouse. You might have some dashboard that shows executives what's going on in the business. All of those are potential clients of validated orders. And since you have a log of validated orders, you can stand up consumers that read those things. Well, suddenly the format, the schema of an order matters a lot. And the Schema Registry is another service. This is, again, a thing. People have literally built this, and then the community built one that is sort of the official one. It's another machine that's running out there, and anytime the producer wants to produce, it says, hey, Schema Registry, have you seen the type of this thing I'm trying to produce before? And maybe it'll say, yes, I have. And I'll say, okay, good news. I'm just going to go ahead and produce that into this topic. Or Schema Registry might say, no, I haven't. That version of the schema is different than the version that's in this topic. And if you produce that, the consumers that are consuming from this topic will fail. So, producer, you get an exception. So the Schema Registry gives you a way of asserting at produce time that the messages that you're producing are compatible with what's in the topic. That's a very, very high-level description of the Schema Registry. Obviously, there's more to say about that, but it's a super important thing. And what it does is, and that, by the way, that that database is actually inside Kafka. That's not a standalone database. That would be silly. We use Kafka for that. Schema Registry encourages us to define our schemas using its own IDL called the AVRO-C or AVSC files. They are a JSON format. That this now becomes code. So the schema that describes the messages and topics becomes code. All the collaboration around schema is driven to this file that's controlled in the Git repo. All the conversations about format change and everything are conversations around the change in this file. Guess what? We already have super good ways of having even distributed conversations about the way files change. So all of the collaboration methods that we have as developers get applied to the way we use schema, and the system helps us prevents us from writing data into a topic that will be incompatible with consumers that read it out later. Now, what do we got? We got integration, we got schema management, computation. If you have the opportunity to talk to people who have been using Kafka for a year or so, ask them, hey, what do your consumers do? What do you do in your consumers? And they'll tell you the same things. They'll say things like, well, we take one stream and we enrich it with some data, and we do some grouping, and we do some aggregating, and we do some filtering. Again, it's kind of depressing, right? You thought that event-driven programming would save you from all you do is put things in databases and serialize them as JSON. There's still only like 5 things that we do. But those patterns emerge, and you don't want to build a framework to do that. Put differently, remember those consumers. There's the trap, right? You're tempted to extract a framework. So you're going to do these things. You're going to take streams and group them. In other words, you're going to take a stream and you're going to turn it into a table. Or a particular stream might be something like updates to user records. It's not really a stream of events, it's a changelog. I might want to take that changelog and materialize it as a table, as the current state of each user. So that's a thing you're going to have to do. Enrich a stream with a table, aggregate, join one stream with another, manage all this state that you're creating, right? That's a hard problem. These are all things that are going to happen in your consumers, and they're all things that Streams does for you. So what Streams is a functional Java API, and by functional I mean the functional paradigm, not an API that works, although it is both. So you're describing with Lambdas the filtering semantics or the grouping or the reducing that you want to do in your aggregator. You pass a Lambda, and that Lambda is applied to all the messages in a topic or in the flow of the stream topology. It gives you first-class abstractions for streams and tables. So it introduces this concept of tables, which is very much worth looking into. We've got a little bit more explanation of that on the Apache Kafka website. So if you go to kafka.apache.org, there are a few videos about Kafka streams there with a guy in them that looks like me. So this seems like a shameless plug. But if you want to hear more about this stream table thing, you kind of have to watch that video. And they help you manage states. This addresses a weakness in the consumer group scaling. Remember I said if you're stateful in your consumer groups, life's kind of hard. If you're stateful in your Kafka Streams applications, life is not hard. You still get to scale out. You could still have those things that are actually Streams applications now. You could still have those things fail and not lose your place. The other interesting thing about this is it's just a Java API. So your stream processing doesn't happen in some special processing cluster. It just happens in the application that you write. It's Java code. Looks like this. Okay, that's a little intimidating. Let's get that off screen. But it's just your application with stream processing functionality built in. Streams is a Java API, gives you all the normal stuff you'd want to do. Very importantly, locates your stream processing not in a special processing cluster, not off in the Spark cluster or the whatever cluster, but it's just in your service. And it scales like a consumer group with state management. Now, this gets us to the final element in our platform, which is KSQL. So, a couple things. Only about half of you are Java developers here, so you're like, that's great, that's a Java API, Tim, but we did tell you that we're not Java programmers. And also, sometimes all you want to do is stream processing. You don't want stream processing glued onto your Spring Boot application, but you just have this topic that you want to aggregate and filter and join and spit out to a new topic, right? It's just real-time analytics that you want to do. Well, in that case, Kafka has a SQL-like language called KSQL. This is actual KSQL right here that's joining a stream to a table and calculating an average and a count. So it's a join, a group, and an aggregation. And this runs on a cluster of KSQL servers. You're kind of seeing a trend. We have a Kafka cluster, and we put all these other processing things around it. And KSQL is one of those. Now, there's a REST endpoint. I can use that REST endpoint to throw bits of KSQL code there, and it constantly runs, constantly consuming from that top topic, right? Taking the data in here, producing to a new topic that can then get consumed by whatever it is I want. So with that SQL-like syntax, that declarative syntax, I get that stream processing done with all of the same stuff I could have done in Java, but now I don't have to. I get to run it on this horizontally scalable KSQL cluster, which gets us pretty much to the end. We have gone from events to SQL with data integration, schema management, all of the pieces that we need in between. Let me remind you who you are. You write programs. In the programs that you write, events come first, and you should really probably focus on writing your program and try to let a platform like Kafka do the rest. Thank you. Have we time for Q&A?
Yeah, we're a little over time. We could try to answer one question with Slido, or do you want to do it? All right, we'll try to answer one question with Slido then. We'll have the questions coming up here shortly.
I'm standing between you and your coffee and your high-carbohydrate snacks, so just one question.
Here are 4 you can pick from.
Okay, why Kafka over a scalable pedigree MQ with richer connectivity and semantics? Okay, answered that, and that was scaling of topics and durability. So it's not a MQ, it's a log. Kafka is a distributed log. And individual topics can scale to be multi-master affairs rather than just single master. Performance testing, your mileage always varies, right? Mark Twain said, there's liars, damned liars, and statistics. If performance benchmarks had been a thing in the 19th century, he would have put them underneath statistics. Always got to be careful with that.
I think we're a little over time, so that was probably good.
I would love to talk more. I'll be around. Thanks.
Yeah, you can find him after and maybe ask him some questions there. Thank you, Tim.
Dude, oh, thank you. Thank you very much.